All right, so let's continue our discussion on direct variation, and this time we'll be applying what we understood about the direct variation equation to a word problem. Okay, so let's say, for example, we have this problem wherein the weight on Mars, which is represented by y, varies directly with the weight on Earth, which is represented by X. So the weights of the science instruments on board the Phoenix Mars lander on Earth and Mars are shown. So the science instrument, when they were weighed in Mars, they weigh 50 pounds. But on Earth, their weight is actually 130 pounds. Okay, so you see that they weigh lesser if they were in Mars. So the question here is, what is an equation that relates the weight in pounds on Earth and the weight on Mars? Okay, so we already know that y, which is Mars, okay, the weight on Mars varies directly. Okay, because of this statement here, we know that we have something that looks like y equals kx. Okay, now we need to find what the value of k is, our constant, the constant of variation. Now, do we have samples that we can replace for our y and x so that we can find our k? So the first thing is we can use these weights that we are given. So in Mars, the instruments weigh 50 pounds, so y will be replaced by 50. We do not know the k yet, so that's what we are solving for. And on this side, the weight on Earth is 130 pounds, right? So solving for k, we have to divide this whole thing by 130. Oops, sorry. It's not letting me do that, okay? So k is now going to be 50 over 130, which you can simplify as a fraction, which is 5 over 13. Okay, you can also change it to a decimal if you must. Okay, so just be flexible, by the way, depending on what Math Excel would be asking from you. Is it going to be in fraction form, or is it going to be in in decimal form? In decimal, if you do 5 divided by 13, this is roughly around 0.38. Okay, so now let's go to our next part of the question. So how will the graph of the equation y is equal to 0.38x, how would it look like? All right, so what we can do is we can assign, so remember our equation now is y is equal to 0.38x. Now, unfortunately, our k is a decimal, so we will need to multiply by higher numbers so that we can get whole number points that we can plot in here. So we can use our x values as 50, 100, 150, okay? So we can have our x values and of course our y values, all right? So if our x is 0, definitely our y is 0. We can have 50, 100, 150, so we can plot those points over here. Okay, so we know that if it is 100, so you just have to move your decimal point 2 to the right, so this is going to be 38. Now 100, the half of that is 50, so definitely the corresponding y value will be half of 38, which is going to be 19. Okay, and then you add another 19 to to 38, that's going to be 57. And so you will notice that if you plot these points, so you will have 0, 50 is 19, so it's almost by 20. 100 is going to be a 38, it's gonna be somewhere over here. And then 150 is 57, it's gonna be over here. You will see that I will try my best. Okay, it's going to be a perfect straight line. You can use a graphing calculator to double check this. It's just that it's so difficult for me to draw a straight line by hand on this without some other tools. Okay, so you will see that this is going to be the graph of the equation y is equal to 0.38x. Okay. All right, so as a summary, when we talk about the graphs of variation, we always have to consider the equation y is equal to kx, and the graph of that will always be a line, and that line will have this following properties. You will have a line that passes through 0, 0, which is our origin, and you will also notice that the slope of that line will always be the value of k, or the constant of variation. So typically when you have a direct variation equation and you need to graph it, this is how it would possibly look like. If your constant of variation is a positive number, it's going to have a positive slope. And if your constant of variation is negative, then you will see that it will have a negative slope. All right. So looking at this, how can you write a direct variation equation when you are given a table? All right. So in this case, we have this data set. We have to find, does y vary directly with x? Okay. And if it does, we have to write an equation for the direct variation. So how are we going to get this one done? So remember, when we have a direct variation, our equation should always look like as y is equal to k over x, all right? The value of k needs to be consistent. So for us, since we have x and y values here, how can we identify if these points show us a direct variation between x and y? What we can do is we solve for k, we find k. And how do we do that? We simply divide everything by x, okay? And so the constant of variation, this is one specific number. That constant of variation should be the same. So it's going to be y over x. So what you can do is, if you divide y and the x values, when you have a table of values, they should have all of those ordered pairs should have the same value when you divide y by x, okay? So let's try letter A. So here you have 6 over 4. So 6 divided by 4, which is what? 3 over 2, correct? Okay. The next pair, it's going to be 12 over 8, and both of them could be divided by 4. And so this is going to be 3 over 2 as well. So far, we're looking good. Now, let's take a look at 15 and 10. So 15 divided by 10, both of them is divisible by 5. And you divide by 5, this is going to be 3 over 2. All right? And as you can see, you have the same ratio between your y and your x. And so this number now is our k. So this is a direct variation. Set A is a direct variation, and the equation will be y is equal to whatever this consistent value, that's the k, which is 3 over 2 times your x. Okay, so that is how you can identify direct variation from a table, and then you can write it down as an equation. So let's see on letter B. Why don't you try this one on your own? Okay, try to see if you will get a similar value when you are dividing y by x, and if you have, then you have a direct variation. If not, it's not a direct variation. Okay, so try letter B on your own. Go ahead. So if you look at the first pair, so you have 3 over 2 over the negative 2, that's going to give you a negative 1.6. The second pair, 2.4 divided by 1, it's going to give you a 2.4. Now, do you still need to continue with the third pair? You don't need to, because as you can see, the first and the second ratios are already different. And so this is not a direct variation. Okay, so remember, you can continue checking and checking if you are getting the same value as the ratio of y and x. But once you have a different value, you can stop. You can already say, oh, this is not direct variation. All right. So a summary for this lesson, if the ratio of two variables is constant, then the variables have a special relationship, and that relationship is what we call as the direct variation. Thank you.